Cloud computing is essentially a transition from an as-a-product to an as-a-service world. While marketeers now suggest everything is available as a service, in relation to cloud computing, there are really only 4 widely accepted service models. The delineation between these service models comes down to the point within the IT supply chain at which the service is being consumed. So starting at the bottom and working upwards, we have infrastructure as a service. This is where the subscriber of the service procures basic processing, storage and networks on top of which they will build, deploy and run their own arbitrary software. Examples of this might be Amazon's EC2. Next is platform as a service. This is where a subscriber builds, deploys and runs their business applications with programming languages, tools and runtime environments supported by the provider. Examples of this might be Microsoft Azure or Force.com. Moving upwards, we then get to software as a service. Here, the capabilities provided to the subscriber is at the application level, normally on a per-user subscription basis. A well-known example of this is Salesforce.com. And finally, at the top of the stack is capability as a service. While this service model is not called out by NIST, it is often discussed by analysts such as Gartner and the Big Four consultancies, including Deloitte. At this level, the subscriber is consuming a business outcome. For example, a payroll service where the outcome is paid staff. On this slide, the various service models can be viewed from a technology perspective. As you move from traditional IT into infrastructure as a service, cross-platform as a service, into software as a service, less of the IT supply chain is managed by you and more becomes managed by the cloud service provider. Along with the 4 service models, there are 4 widely accepted deployment models. The delineation between the deployment models is the extent to which the service is shared in relation to the organizational boundary. The private cloud is solely used by a single organization. It does not matter whether the cloud service resides on or off-premise, although sometimes this distinction is drawn and an off-premise private cloud is known as a virtual private cloud. Private cloud comes about as a response to risk, where businesses want to realize some of the benefit of cloud but do not want to take the risk of transition into the public cloud. Critically, however, there is a cost premium associated with this, as private clouds are often more expensive. A community cloud is used by a group of organizations who share a common interest. Perhaps the most often cited example of a community cloud is a government cloud, whereby public sector agencies share similar needs in terms of information security. The public cloud is the model most well known and is a cloud shared widely by many individuals and organizations, from you and I at home with our credit cards to large enterprises. A hybrid cloud, then, is 2 or more of these other cloud models being used in conjunction with one another. This is likely to be a popular model as business looks to balance the trade-off between risk and cost by spreading the data and workloads across the public cloud and their own private cloud, maximizing the utilization for their private clouds during troughs and bursting into public clouds during peaks. In addition, and perhaps of equal importance, is the nature of the applications these deployment models are designed to support in relation to where and how design for failure and scalability are considered. Legacy enterprise applications tend to rely on highly available infrastructure and scale vertically. These applications are not well suited to maximizing the benefits of cloud as they require expensive resilient infrastructure. That said, the cost to re-architect these applications is considerable, and so providers are coming forward with highly resilient cloud service offerings. The next generation of web-scale applications, in order to maximize the benefit from cloud, will be designed to cope seamlessly with failure of infrastructure components and to scale up and down horizontally in line with cloud services. These applications can then safely use lower-cost clouds built on cheap commodity hardware. Clouds do fail, as reported in the press for Amazon, Google and Microsoft. So in response, applications will likely be deployed across multiple clouds, as it is rumored for Apple's iCloud being striped across both Amazon and Microsoft clouds. However, not all applications will be redeveloped as web-scale applications, in the same way that some applications did not get moved from mainframe to client-server. Each application must be taken on a case-by-case basis.